Okay, class, so now we're going to be working on lesson 15.2, modeling exponential growth and decay. So, of course, you're going to first start out by writing your essential question. How can you use exponential functions to model the increase or decrease of a quantity over time? So, if you notice, this is very similar to what you learned yesterday, right? So it's the same thing. All you're gonna do is, again, come up with the equation, graph it on Desmos, and get the answer. So let's begin. First of all, over here, you have to describe the end behavior of a growth function. Now, in case you don't remember, this is something that we learned in chapter 14 or module 14, right? So again, when you graph a function in a coordinate plane, the x-axis, blah, 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 okay. In other words, what that means is you have a graph like this, okay? When you follow the graph, you would figure out that as you move the cursor to the right, the end behavior increases without bound, okay? Do you know what that means? You see this over here? We have this graph over here and we're going to follow it, okay? Let's just pick a point over here, okay? Let's say that this point is 1, 2, 3, 4, 5, 6, 7. Let's say this is -7 on the x-axis, okay? On the y-axis, what do you think this is? Let's just say that this is 1, okay? So when x is -7, y is 1, right? So now let's pick another point, like this one right here. Now your x is what? 0. Now what is your y value? Well, let's call it 2. You notice how as x got bigger and bigger, what happened to the y value? It went from very low, which is like at 1, even lower than 1 actually, to 2, right? So now let's pick another point, say like let's pick this one right here. Okay, so then what do you think the x value would be? I don't know. I'm not really good at drawing straight lines. Let's just assume that it hits this one, right? So that's 1, 2, 3, 4, 5, 6, 7. Let's say that when your x value is 7, what is your y value? Well, let's take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say it's 9. So it doesn't matter if your number is accurate or not. You just have to get the idea. X started from -7, went to 0, and 7. So what's going on? X is getting bigger and bigger. And if this line went on and on and on this way forever, that means x increases to infinity. And when x goes towards infinity, to the right and right and right and right, which way is y going? Well, we started from 0 and then 2 and then it went to 9. And then as you can see, if this graph continued on, you would realize that it goes up and up and up and up and up. And so what did I say? Mathematically, how do you express up and up and up and up and up? Y goes to infinity. Infinity goes up and up and up and up. Okay? So now let's go ahead and investigate something else. Now let's start backwards. Okay? Let's start from here. And then let's go backwards. So we're going to just select the same points here, here, and here. And so this time let's start with this number. Let's say it's 1, 2, 3, 4, 5, 6, 7. Let's say this is 7. When your x is 7, what was your y value? I think we said 9 or something like that, right? Okay, but see, this time we're starting from the right and we're going that way. Okay, so we're going which way? X goes to the left and 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 left forever. Okay, so mathematically, how do we express it? As x go to negative infinity. Remember? Negative infinity. What happens? Well, the y value, this is the y line right here. It was a 9, and then remember this point? When x is 0, right? What was my y? This is 2. Okay, so then we're going some more down way here, and it's 1, 2, 3, 4, 5, 6. I think we said this is going to be like -7. And what is my y value? Very close to 0, yeah? Less than 1, very close to 0. And let's see, let's say that this keeps going and going and going and going and going and going forever and ever. Okay, it should not be a curvy line like that, okay? But anyhow, let's say it kept on going. eventually, where do you think this line would meet on the y line? Well, if you look carefully, it gets really, really close to 0 on the y line, right? So how do we express that? As x goes to negative infinity, y goes to 0. And that's it. That is what end behavior is. So please make sure you understand this is what end behavior is. End behavior is as x goes into infinity, y goes into infinity, and as x goes into negative infinity, y goes to 0. So you just have to be able to look at a graph and describe it. Okay? So then I want you to go ahead and fill all this out. And then if you go to the next section, it's the exact same thing. But this time they give you a decreasing function like this. So then it's going to look a little bit different, right? And I don't want to kill it for you, but here. X, as x goes into infinity, we're starting from here going down. Where's y going? Y is getting closer and closer to 0. As x goes into negative infinity, that means we're going to the left, right? Going this way. What happens to the y? It looks like y is getting bigger and bigger and bigger, bigger, into infinity, right? Okay, so again, this is the end behavior. The end behavior of an exponentially decaying function. Okay? So again, very important, scroll down, study. Okay? And of course, Mr. Berger does a great job with his videos over here. Please make sure you highlight and understand the vocabulary words. Exponential, exponential growth model, and this is the formula. But hey, you already knew of this formula because that was what we were working on yesterday. And again, same thing. What was the A? That's the initial amount. And then 1 plus R is the growth factor. Remember, the wolves were growing at a rate of 15%, and so the R was 0.15. So you had to go 1.15 raised to the n power yesterday. And how many wolves did we start off with? I can't remember. I think that was 225. And we wanted to find out how long it took for the wolves to have a population of 500. Okay, I hope you remember that. Anyway, R is the growth rate, usually in percentage, and T is the time, and we did that, right? Instead of T though, we used N or X on our graphing calculator. Anyway, the value of the model increases with time when we have that. However, sometimes we have decaying functions, and that's going to be the next page, but let me just go ahead and take a look at this right here. So we already know. Let's take a look at this question. A rare comic book is sold for $3,000 and its value increases by 7% each year. So find the value of the comic book in 10 years. So now what we're going to do is we're going to set up an equation. It's a little bit different from yesterday, but it's still the same equation, okay? It's just that we don't have an answer. So we're going to say y is equal to, just because all your multiple choice option here starts with the y. Okay? And then, what was the initial value? The comic book, before it went up in price, is $3,000, okay? But then, once you buy it as time passed by, it's going to get more and more expensive, right? Which is why people, keep collections and then sell them later on. Okay, so what do you have to do? Remember, 7% is what in decimal form? 0.07. But I talked about this, how if you just multiply 0.07 to 3,000, it's going to be less than 3,000. That is how much it increases by. So you have to add that to the 1. So that's going to be 1.07 raised to the power of t. But hey, that was yesterday, and they gave us the answer. But today, they want the answer, and they only gave us the time. So that's even easier, right? Instead of t, what are we going to put? We're going to put 10. All right? So, where is it? Oh, wow. They made it super easy for you, so you obviously know that this is the correct answer, right? I did the 1.07, but that means 1 plus 0.07, I talked about it right here. And of course, I wrote the t in the beginning, but it already gave us the number 10, so we can just plug that in. Let me just click on this to show you that this is correct. If you check, here's the check mark. And then when you go down, obviously, they plugged in the 10. And then you have to put this in your calculator and plug in the correct answer. Okay, here's the calculator right here. Scientific calculator. And so what number am I going to plug in here? 3,000 times. So don't forget exponents first, right? So it's 1.07 raised to the 10 power. 1.07 raised to the, there you go, you have to click on this one. Raised to the power of 10, okay? So you do that first, and then you have to multiply that by, let's go back. You have to multiply that by 3,000. 3,000. And so that's the answer, $5,901 and all that stuff, right? It was in dollars. Okay, so then it says round to the nearest hundredth. Do you know what that means? Nearest hundredth means two numbers after the decimal. 4, 5, okay? So after the 5, what do you see? A 4. You know what that means? If the number behind the 5 is less than 5, you just drop everything. So your answer is 5901.45. 5901 point, and I forgot already. What's wrong with Miss Choi? 45. There you go. Check your answer, and of course that's correct, right? And so make sure you do the same thing. And so it says after 10 years, the comic book will be worth approximately $5,901.45. Wow, you could have gotten the answer just by looking here, but of course Miss Choi did not. All right, so then go ahead and continue working on that. And here is a question that is similar to your homework question. Well, let's take a look. As usual, I'm gonna try and zoom in for you so you can see. Sarah sold a coin for $3 and the value increases by 5% each year after it is sold. Find the value of coin in 6 years. Wow, today's lesson is so much easier than yesterday because you don't even need the decimals calculator. You can just get it done. And in this question, actually, all you have to do is just look at the graph here and the answer is given to you. Sarah sold a coin for $3, okay? So in the beginning, which is 0, how much do you have? $3, right? And then the value increases by 5%. They already graphed it for you. Find the value of the coin in 6 years, okay? So 0 years, 3. So 2 years, 4 years, 6 years. In 6 years, how much is it going to be? 4.02. But let's pretend, they made it so easy for you, but let's pretend that you didn't have this. How would you do it? You start with 3, because that's your original value, and it increases by 5%, which is 0.05. So you're going to go 1 plus 0.05, raised to the power of what? 6 years. And when you plug that into the calculator, you'll get 4.02. All right? So then let's just plug in the number. This is such a no-brainer. I am actually sad. Okay, of course it's correct, right? Because they just practically gave you the answer. Just in case you don't understand this graph, you know, it's supposed to go like this and then grow exponentially forever and ever and ever. Okay? All right, now let's move on. Okay, modeling exponential decay. This is just like the other part, okay? It's just that you see the word exponential decay model. What that means is now you're subtracting from 1, okay? So it's the exact same equation you're using, but you're going to be subtracting because it's decaying. A is still the initial amount, 1 minus R is the decay factor, R is the rate in percentage, so you gotta change it into decimals, and T is the time. And so I'm not going to waste any more time. Let me just go ahead and go straight into the question here. Science lab has 400 kilograms of a particular isotope in storage. This isotope loses 3%, that's your rate, of its mass every day through radioactive decay. How many kilograms of the isotope will be left over after a week? Just seeing the word decay means you already know that your graph is going to look like this. And that's the opposite of the previous question, right? So what do you start off with? Initial amount, 400. What are you going to multiply it by? 3% is 0.03. But it's decay. The graph is going to go down, right? So what are we supposed to do? If there were no changes, it would be 400 times 1, right? But every single time, every single day, right, we're losing stuff. So we're going to be subtracting 0.03 from 1, okay? Which is going to be what? Oh, right here. Which is going to be 0.97. In case you don't understand, this part over here is 1.00 minus 0.03. So it's like 100 minus 3, kind of like, but the decimal is still here. Okay, so there you go, 0.97. Raised to the power of, after a week is how many days? 7. It has to be a small 7, not so big like that. Raised to the power of 7, and that will be your y. And of course, I go into too much detail because you can already tell what's your answer. It's this one right here. And to prove it to you, of course, I have to select it and then check my answer. That's correct. And of course, instead of t, that's 1 week, you have to plug in 7. That's your answer. First, don't forget, whenever you plug stuff into the calculator, you gotta do exponents first and then multiply by 400. That's what they're showing you. 0.97 raised to the 7th power is 0.808, and then you gotta multiply that by 400. So should I just guess over here? Okay, I can't do it. I'm going to actually multiply. Unless they have the answer down here. Yes, 323.2. Now, I don't even know why they do that, but okay. That's why you use this page just to study. Okay? Anyway, so make sure you scroll all the way down, and here is my favorite video done by Mr. Berger. This video, I promise you, is a million times better than Miss Choi's video. Anyway, keep going. Here's your homework question. Same thing, let me scroll down. I'm hoping that this is already big enough for you. Let me check. Yep, it is. The value of a boat is depreciating. Depreciating is another decay thing. Graph's gonna look like that. Okay, 8%. Okay, that's your rate. In 2006, the boat was worth that much. Find the worth of the boat in 2013. All right, so for this one, you gotta use a little bit of your brain. So to come up with the equation, what do? Y is equal to, and then what was the initial price? Oh, it was worth 17,000. And then we're going to multiply what? It's decay, so we have to subtract 8%. 1 minus 0.08 raised to the power of time, okay? And that's what y is equal to. But for time, what are you going to put? The beginning was 2006, but now they want to know the price for 2013. So how many years have passed? In year 0, it was 17,000, right? So all you have to do is go 13 minus 6, or in other words, 2013 minus 2006. That way, you would know how many years have passed. So 13 minus 6 is 7. So instead of t, you're going to have to plug in 7 and then put in your answer. Okay, so I'm going to go ahead and put that in. What is 1 minus 0.08? Yes, 0.92. So that was 17,000. And then you have to multiply it by 0.9. Oh, did I say? Oh, yeah. 0.98. And then you have to raise it to the power of, wait, no. And then you have to raise it to the power of 7. No, I think we're supposed to put t, right? Okay, next. Yes. Oh no, what happened here? This is correct. Oh, it's because I didn't put it in the answer. I just wanted to check my answer for this side. Okay, so anyhow, this is correct. Once you put in the put this in the calculator, you'll be able to get the correct answer. Okay? Don't forget to plug in the 7. Oh, they have multiple choice questions. What's wrong with me? So let me see if I could go back. Nope, I cannot. But anyhow, so let's take a look, okay? So what are they looking for? They're looking for what's going on after 7 years. So look at the graph. And obviously you already know that the graph looks correct. On this one only. And so this would be correct because you start off with 17,000 and slowly the value goes down. Okay? So B would be your correct answer. All right? So let's go ahead and check again. Okay, what else are they asking? All right, so part 2 is correct, but they said that part 1 is wrong because I didn't put in the correct answer over here. Okay? Finally, part 3 out of 3. Enter the functions domain and range, and then we have to explain why the y-intercept what the y-intercept represents. Okay, what is the y-intercept anyway? That is the initial value, the $17,000. So how much the boat was worth? How much the boat was worth in 2006? So 17,000, the value of y when t is equal to 0, when time was 0, which is the original value, okay? The domain is what? So time is going to start from 0, okay? So the domain means the x value. So if you look in the graph, you start with 0 because you cannot have -1 days. You start with 0 and keep going on and on and on, right? And the range is a set of real numbers. Just so you know, range means the y values, okay? And so when we talk about the y values, we're talking about how much the boat costs, right? So can you have negative whatever dollars? No. So you can only start from $0 and up. So you have to start with 0 and go all the way to, well, is the graph going to go up higher than $17,000? No, because we are starting from $17,000 when you purchase the boat, and then the price keeps going lower and lower and lower. So we're gonna only go up to $17,000. Okay, so let's go ahead and check our answer, and of course everything is correct. I really apologize for not plugging in all the numbers here before checking, because now you're going to get confused because you think I did it wrong, but it's not wrong. Okay, so this homework question is actually kind of intense, huh? So please make sure you focus on that, because if it was intense, it's probably going to show up on your test, right? So now the very last question is something where you would have to use your application after learning all this stuff. And Mr. Berger does a fantastic video over here, so I'm just gonna leave you with this. And then I want you to work on your homework question, which kind of sort of looks like this. And it's not popping up for me right now. So anyway, that's it for today. If you go into the student edition, that will be the second link in your Google Classroom. You'll be able to see all your homework questions. And most importantly, if you did finish your homework, what are you supposed to do in my classroom? Yes, you're supposed to start working on the evaluate section. There's a reason why I have boards all over my classroom. You're supposed to be working on these questions with your teammates, and I will come by and help you, okay? And I told you don't have to solve every single one of them, okay? All right, so happy learning.